In lesson 9, we are going to be looking at side, side, side triangle congruence. So we're going to be doing, let's see if we can prove one more set of conditions that will guarantee that two triangles are congruent if we see them. So we've already done this a couple of times. So we've talked about if we have two triangles that have this information. They've got two sets of sides congruent and then the angle between them congruent. That's enough for us to know that those two triangles are identical in shape and size through side angle side congruence theorem. The second way that we've looked at is if we see this information. So two sets of angles and the side between them are congruent. Then that guarantees these triangles are congruent, and that's called angle side angle. So today we're going to be looking at one more that will guarantee that triangles have the same length. So in 9.1, you'll find it on page 228. Your task is to take linguine pasta and create a triangle with the lengths that you see in your book. So lay the linguine pasta down on these and break it so that it's this length, okay, for each of these three. Then you just need to create a triangle. Once you have your triangle created, you're going to compare to anybody else's in class, okay? So can you make a triangle that doesn't look like anybody else's? So once you've created yours, I want you to go and look at other people's triangles. So if you need to snap a picture of your triangle so that as you're walking around, you can be comparing so you can remember what yours looks like, that's fine. And I want you to take 2 minutes to do this, okay? So 2 minutes to create this triangle and then go look at a few other triangles in class and see if you can find anybody that was able to create a triangle that looked different than yours, or if yours is different than anybody else's. So pause the video, do that, come back in 2 minutes. All right, so hopefully you created your triangle and then you went around and you looked at other people's triangles. And were you able to find any that looked significantly different than yours? So probably all of them looked something like this. Maybe they were upside down. Okay, so maybe they looked different in the way that the person set them on the desk. But you were able to think about rotating or reflecting to get them to be the same triangle. So none of them were significantly different than anyone else's. Okay, and this is because of side, side, side. So we're going to be looking into if we know all three sets of side lengths are congruent, does that guarantee that our triangles are congruent? So on the same page at the bottom, so page 228, at the bottom you'll see activity 9.2. And so we are seeing that Priya is given a task to explain why side, side, side triangle congruence will work. So she's going to come up with doing a proof of why this will work all the time. So what I want you to do right now is I want you to take highlighters or colored pencils, and I want you to use 3 different colors to connect the congruent pieces that you see. So if you read through that sentence, if you read through that paragraph in the book, it says it. It's also here on the screen. And so I want you to highlight the congruent or these pieces of information in the picture. So I'll do this first one. So segment ST is congruent to segment GH. So I want you to highlight it and highlight it on the picture. So you can pause the video and get that done. So TU to HJ and SU to GJ. You can also put tick marks on the sides to show which ones have the same length and are congruent to each other. And then what I want you to do is go through this fill in the blank proof that Priya has set up to explain this and fill in the blanks trying to follow along with her logic. So pause the video and then go through and try and fill in the blanks. And then for about, I would spend maybe 5 minutes on this. And then come back and we'll talk through it. Okay, so ST is the same length as what? And you've already highlighted these. So ST is my yellow segment. So congruent to GH. So ST is the same length as GH, so they're congruent. Therefore, we know that there's a rigid motion that will move them together. Okay, that will take ST to GH. So then it says apply the rigid motion, which I just did, moved them over. And so the image of T will coincide with H. And the image of S will coincide with G. And then we can't be sure that U and J will be on top of each other yet. Okay, so she's just saying we can't be sure that U, which we're just going to call U prime, will coincide with J, its like part. Yeah, so if it does, then we're done. So if all it took was to get this yellow segment together and J landed on U, then our proof would be done. If not, then we need to continue. Okay, and mine didn't land on top of each other. So HJ is congruent to the image of, so HJ is congruent to the image of TU because a rigid motion preserves distance. So therefore, H is the same distance from U as J. And then a similar argument would say, so now we're saying H is the same distance from U and J. And then a similar argument would show that G is the same distance from U as it is from J as well. So GH, so now what we have here is since we know that these are the same distance away, then GH is actually the perpendicular bisector. Of this segment UJ, because it's equidistant. H is equidistant from U and J, and G is equidistant from U and J. So because the perpendicular bisector, I'm just going to shorthand that with the symbol perpendicular bisector, is determined by 2 points that are equidistant from the endpoints of a segment. So now we showed this point, same distance, this point, same distance. So if we do a reflection across the perpendicular bisector, so if we do a reflection across the perpendicular bisector, again, I'm just going to shorthand this, of UJ, that would take J to U. So what we've done here is we've shown that T is coinciding with H. We've shown S coincides or lands on G, and now we just showed J will land on U. So therefore that proves, since we got all three vertices to land on each other, that the two triangles are congruent. Okay, so it proves that GJH is congruent to SU, what was the other letter? SUT. So then what this means for us now, and you're not going to have to be able to redo this proof like this, okay? But what this proves to you now is that anytime you see two triangles, okay, that have the exact same sets of sides as each other, then these two triangles are definitely congruent, okay? And this is by side, side, side. So anytime you can get all three side lengths to be equal in a triangle or see that happen, you automatically know the triangles are congruent. So in this next activity on page 231, we're going to be drawing a parallelogram, and our goal is going to be to prove that angle B is congruent to angle D. So let's go ahead and get a parallelogram drawn. Okay, so draw a parallelogram there on page 231. So if you need to pause to make sure that you get your parallelogram drawn, that's fine. So label the sides A, B, C, and D. And what we're going to be doing is we're going to be creating, first you're going to be doing a draft of a proof. So remember, our goal here was to prove that angle D and angle B are congruent to each other, given that we have a parallelogram. So let's be reminded of the things that we know to be true in a parallelogram so far. So we know by definition of a parallelogram that the opposite sides are parallel. Okay, so we for sure know that, and we'll be able to use that in our proof if we need to. The other day, we also proved that opposite sides are congruent to each other. So we know that AD is also congruent to BC. We also know that AB is congruent to DC. So those are things that we know about the proof. So how do you think you're going to be able to prove that angle B is congruent to angle D? I want you to write about this for 2 minutes. Okay, so I want you to pause the video and I want you to write a plan for your proof by yourself, okay, on a sticky note. So get a sticky note. You're going to set a timer for 2 minutes and write a plan for your proof. Then come back to the video for the next step. Okay, now that everybody has their first draft, okay, so you've written a first draft for your proof on a sticky note. I want you to find somebody, I want you to go and compare your proof to a partner. Okay, so find somebody else to talk to, read them your proof plan, then have them read theirs and discuss, what do you know? Okay, what does each person understand that about the proof, and what do they still need to get completed? Because maybe you didn't get to finish your proof. Okay, so what do you understand and what revisions could you make to move forward? So I want you to spend 3 minutes on this. So 3 minutes. So pause the video for 3 minutes, compare with a partner, and then come back to the video. So now that you've compared, I want you to write your second draft. Okay, so I want you to rewrite your proof. Even if you liked your first one, everybody needs to rewrite it. And I want you to put it in your workbook. So I want you to do this second draft in your workbook. And if you want some sentence starters to help you, here's a couple. So you could be saying, first I know this because, next I know this because of, then I know, therefore, and ultimately at the end of your proof, you need to have your conclusion of what you were trying to prove. So at the end of it, you should say, all of this means that angle B is congruent to angle D, because that was the goal. So I want you to take 2 minutes again to get this second draft written into your workbook. Then you can come back to the video. All right, so I think there's 2 different ways that you probably tackled this proof. So one of them is potentially using the idea that we saw that AB is congruent to CD and A is congruent to B, combined with the idea of an auxiliary line. So adding in a helper line to split it into 2 triangles. So maybe you saw something like this and you're like, if I can prove these 2 triangles are congruent, then B would have to be congruent to D. So maybe that proof looked something like this. First, I know that AB is congruent to CD because opposite sides are congruent in a parallelogram. And then same thing, a similar idea here, AD is congruent to BC because they're opposite sides in a parallelogram. So then you also know that AC, okay, in this bottom triangle is congruent to AC in the other triangle because they're the same segment. Okay, we talked about that in our proofs the last couple days. So we know that this segment is the same in both triangles. Now I see all 3 sets of sides. So then I know that triangle ACD, so ACD is congruent to, and if you watch the way I followed this, I went on the 3 tick mark side to 2. So I got to go in that same order. So CAB in the second triangle by side, side, side congruence that we talked about today. This means that D and B must be congruent because they're corresponding parts. Of congruent triangles. So maybe you tackled the problem that way. You said, I'm going to be able to prove that these 2 triangles are congruent, and then went ahead and did that. Another proof that I think maybe some people might have done is by using the fact that we know these lines are parallel. Okay, so then we know this line is parallel. We know this is parallel to this. Okay, and then so maybe you noticed you could use corresponding angles. So you thought, well, hey, I'm trying to prove that these angles are congruent. So if I said that I see this, let me get this on here. This angle here, okay, is let me get this other line drawn in here. Okay, so if you said, man, I kind of see that this angle is congruent to this one, okay, because of corresponding angles. And then this one is congruent to this one by alternate interior. So B and D would have to be congruent. So maybe you tackled the proof that way. In which case you probably needed to add a letter here to be able to name this angle out here. So maybe you said, first I know angle B is congruent to angle EAD. Because they're corresponding angles. Then I know that angle EAD is congruent to angle D in the parallelogram because they're alternate interior angles. Then I know, okay, and you don't even need this step, so B and D are congruent. So then I know B must be congruent to D because all of these are congruent. And this is really transitive property if you want to get the math word in here. So because of transitive property, which is you knew that angle B was congruent to angle EAD, and angle EAD was congruent to angle D. So angle B has to be congruent to angle D. That's transitive property. So I think you could have tackled it 2 different ways. Either way is completely fine. And then what does this actually tell us? Okay, so what does this actually tell us? This tells us that if we have a parallelogram, we now know that opposite angles are congruent. So you don't have to prove that anymore. Anytime you have a parallelogram, you know that. So now we know that opposite sides are parallel by the definition of a parallelogram. We know that opposite sides are congruent to each other because we proved that the other day. And now we know that opposite angles are congruent. So if I know this angle here is 40, then I know this one is 40, which would force this one to be 140 and this one to be 140. Then on your reference chart, you can add this in for lesson 9. So you can pause the video, get this written down. And then you can pause the video again and get this one written down. Then you have your lesson summary on page 232. So it just recaps what we've learned. So some ideas that you've learned so far, right? We've now got side, angle, side. We've got angle, side, angle. And now we have side, side, side. So when you're looking at a problem, now you're going to be looking at trying to decide which of these 3 would be easier to use. Okay, so if you look at it, is it going to be easier for us to find 2 sides and an angle between, 2 angles and a side between, or all 3 sets of sides? to prove that the two triangles are congruent. So if you can get any of those, then you could prove that the triangles are congruent. So learning targets for this lesson, hopefully you can explain why the side-side triangle congruence works. That was from Priya's proof. And then you can use it like we did in the parallelogram to prove that the two triangles are congruent to help us with some other information. So if there's time, you can go ahead and look at this cool down on the screen, talk to each other, so talk to your groups about these three problems and how we would go about using side, 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 angle, angle, or if none of them work given the information in the picture. So in this first one, to prove that the two triangles are congruent, we, again, look at it, see what you can think of. I see a circle, so I'm thinking, okay, the radii are congruent. And then also I see this AD is in both triangles, so that one's going to be congruent to itself. So now I see three sets of sides, so I could say these two triangles are congruent by side, side, side. Number two, how are we going to prove these two triangles are congruent? So for this one, we can just see that EH is congruent to itself. But that's not, we have nothing to talk about EJ and EI and nothing to get another angle. So we're not seeing any of these. Okay, so we're seeing none of the above because this is two sides, but not the angle between. Number three, so we see radii again, this exact same segment in both, and then they gave us this angle. So it looks like this one has two sides and the angle between those sides. So we've got side, angle, side for that one.